Okay, so on this assignment, what you're going to see are the other two ways that you can easily identify that you are looking at similar triangles. So remember what similar triangles are. If you have two triangles that have the same corresponding angles to be congruent, so real quick, like this angle right here has a 1 marking. He's A. This angle right here, I'll call him D. Notice they both have 1 arc. This one up here, I'll call B. I'll put 2 arcs on him. This one here, I'll call E, 2 arcs. All I'm doing is showing you that these are correspondingly congruent angles. And like you saw in the previous assignment, if you can identify two angles that are in fact congruent in the two triangles, then you can say that they're similar based on the angle-angle similarity. Since I know these are similar, I'm going to finish this off. I know that this side here, AB, corresponds to, and I can create the little proportion for it, DE, because this angle has 1 arc, double arc, 1 arc, double arc. So these correspond, which just means that they're in the same exact position in the two different triangles. BC corresponds with EF for the same reason, and then the other two correspond. And all I'm doing over here is setting up these ratios, and when I put an equal sign in the middle, that's showing us that the whatever this number is here, and I put the other corresponding side underneath, this one DF, whatever this number is here, when I reduce each one of these fractions that represent the lengths of these two triangles, the fractions are all going to be the same. That's saying that they are proportional sides. So if you have congruent figures, you have corresponding sides to be proportional, same fraction, and corresponding angles to be congruent. The similarity symbol is that little tilde. So I'm saying that triangle ABC is in fact similar to triangle DEF. And like I had mentioned before, you just got to make sure the names that represent those little vertices are in the correct spot. D corresponds with angle A, E corresponds with angle B, and C and F correspond. All right, so that's what similar triangles are all about. In this particular lesson, though, the only thing, I hit too many buttons down here. The only thing you need to focus on for this lesson is identifying why your two triangles that you're looking at, why are they similar, if they are, okay? Now, there's 3 ways to prove that they are similar. The first way was angle-angle. If you can find 2 angles in the 2 triangles to be congruent, then you can say, yep, both of the triangles are similar. Now, the other 2 ways, there's only 3, the other 2 ways are identifying 3 sides are proportional to 3 sides in the other triangle. Just like I showed you, I wrote it over here. If I can set up the corresponding sides as fractions, if each one of those fractions are the same fraction when I reduce them, then I can say that they are similar because of side, side, side similarity. Okay, and this one is saying side, angle, side. So it's a tiny bit different. It's describing 2 sides and a little angle right there in the middle of the 2 sides. That's why the little A is in the middle of the 2 S's. So it's the side here. It's the side here that are proportional in the 2 triangles, and then the angles in the 2 triangles are in fact congruent. So it would look something like that, where you got the 2 angles, same spot, those are congruent, and your 2 sides are similar, same fractions. All right, so that's what we're going to see in this assignment. So I'm going to look over some of these pictures that I have here. This is not working too great, but give me a second. All right, here we go. Okay, so in this, over here on the left, This one's describing the side, angle, side. Okay? So remember, if you can't prove your two triangles to be similar in one of the three ways, angle, angle, side, or side, 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 you say they're not similar. So here's an example, and here's some words you can go back and read. This is describing what I just said. Here's an example of two triangles where you can see you've got an angle here, 75. You've got an angle here, 75. So that's the A in each one, meaning the A's are the angles and they're already congruent. And then you've got this side to be 15 over here. That's a side. And then over here, you're looking for the corresponding side. And that would be the 14 right here. And the reason I am identifying the 14, or maybe I shouldn't, I think I better double look at that. I just assumed. So let me just double check that before I circle that. I just grabbed the 14 because it looked like it. Let's double check. The reason, let's see, this number here is 15. He's the smallest. He's with the A. And then the other number that goes with the A, the side for the angle is 75, but the side right here adjacent is 21. He's larger. He's smaller. Over here, though, he's larger. So he's going to go with the larger side. He's going to correspond with the 21 because he's larger. And this X right here, excuse me, this 15 and this 10 are going to correspond because these are the smaller of the two. So it's as if this whole triangle was turned around. So you do sometimes have to really, really look to see who corresponds with whom. All right, so this guy right here corresponds with this one, meaning if I take 15 and I create that fraction and I put underneath the side that corresponds, there's 15 over 10. I have the angle and the angle right there. So those angles are definitely going to be congruent, so that's good. And then I have the other two sides, which is 21. Since I started with 15 on top, I have to use the 21 here. 21 over the 14 right there. If these two fractions are the same fraction, when I reduce my fraction, if they both have the same number, then that means that these two fractions are equal and that the two sides are therefore, in the two different triangles, are therefore proportional. So I'm going to put them in my calculator real quick here, on my phone real quick. Let me grab my calculator real quick. Calculator. All right, so this one was 15 divided by 10 on the left, and that's a 1.5 in my calculator. And then this one over here, 21 divided by 14, and that's also a 1.5. So because those two sides, this 15 and 10, if I'd made that fraction, it's the 1.5. And then the 21 over 14 is also 1.5. And then I have the angle right there in between the two. Then I can say that these two triangles that we're looking at are in fact similar triangles because they meet that criteria of side, angle, side. All right. And then the other one over here is saying, well, if you have these two triangles and all you can see are sides, create these little ratios with the sides and see if they give you the exact same fraction. So here we go. Like this guy over here, that's the smallest, is 4. This one is 5. So those two go together. So I'm going to go 4 over 5. That's me comparing those two sides. That's all fraction is. It's a comparison. It's a ratio. I can either write it as a fraction or you can write it with these little dots in between. And then I'm going to compare the 6, which is the next smallest, to the 7.5. So I'm going to put 6 over 7.5. It's very difficult to write with this. And then I'm going to compare the 8, which is the last one on the left triangle, and comparing it to the 10. They both are the largest sides. And then once again, I'm going to put those into my calculator and see what I get. That's 4 divided by 5. It won't reduce, but it's 0.8. If I want to just look at it as a decimal, that's 0.8. And if it equals to the other two, I'm good to go. So that's a decimal right there. 6 divided by 7.5 is 0.8. Okay, so far, these first two come out to be 0.8. All right, and then I'm going to do 8 over 10, and that is 0.8. I know what that one is. That is definitely 0.8. So each one of these are the exact same fractions, even though they don't look like it at first glance. So because each one of these ratios are identical to each other, I can say that those two triangles right here are in fact similar because of the three sides being proportional. All right, so that's all you're doing in this particular lesson. You probably have a question where you might have to identify the angle-angle similarity. But other than that, it should just be you looking at identifying whether the two triangles are in fact similar. And if they're not, you say they're not. So if you can't prove it from either angle, side, or side, then you would say, no, they are not similar. And that's all you're doing. Whoops, wrong button here. That's all you're doing in this assignment. And then for future reference, you do have the notes and the practice on here to look at. I'm going to turn this off.